Hello everyone, let's solve the next question. Here we are given a riverboat problem. This is the width of the river, which is 30 meter, and we have to find and we are given that velocity of river is 4 meter per second. Let us suppose the river is flowing along this direction and the velocity of boat with respect to river is 5 meter per second. Now we have to find the shortest time to reach from this end to this end, and when this shortest time occurs, and we have to then we have to find the net velocity of the boat, and we have to also find the drift in that case. Let's first see the diagram. Now here we can draw the vector representing VR vector. This is the velocity of river. Now suppose this is VBR vector, that means velocity of boat with respect to river, and suppose this angle is theta. Then the time required from going from this end to this end is t is, suppose we are finding the time while moving along this straight path, because we know the width of the river is distance is 30 meter along this direction, and along this direction the speed will be VBR cos theta. VBR cos theta. Now we have to find the minimum time. For this to be minimum, for this value to be minimum, these values must be maximum. Now this value will be maximum when cos theta is equal to 1. For t is equal to t minimum, cos theta must be equal to 1, or theta equal to 0 degree, because we know that cos 0 is equal to 1. That means this angle is 0. Then the VBR vector will lie along the path AB. We have found this conclusion mathematically. This is VBR vector. So therefore T minimum is 30 upon cos theta is 1. Now VBR we are given as 5. So this is 6 seconds. This is the minimum time. Now we have to find the net velocity of the boat. This vector represents the net velocity vector, VB vector, because we know that VB vector is equal to velocity of boat with respect to river plus velocity of river. This relation comes from this relation, VVR is equal to VB minus VR. If we take the VR vector in left hand side, then we will get this expression. So if we join these two vectors vectorially, we will get VB vector. Therefore we can write VB vector's magnitude as square root of VBR square or plus VR square. Here VBR is 5, to 5 square plus VR square, which is 4, to 4 square. 5 5 25, 4 4 16, to 4 root under 41 meter per second. This is the net velocity of the boat with respect to ground, and this represents the direction. Now we have to find the drift. Here the particle will reach from position A to position C. Here BC represents the drift. We have to find BC. For this, let me write these expressions. Here we have got time t minimum as 6 seconds. Now we have to find the drift. Here the drift will be BC, and its magnitude will be this is the distance BC is equal to speed into time. Here we have to find the speed along this direction. Along this direction the speed is VR, which is 4, and the time required from going from B to C is same as going from A to C with VB speed, which is 6 seconds. So this is 24 meters. This is the answer of this question. Now let's move to the second part of this question. This is the first part asked. In the second part, we have been asked Can the boat reach a point just opposite to the just opposite on the other shore? That means in the second part it is talking about the shortest part, which is AB, shortest path the boat will take. That means in that case the net velocity will be directing from A to B. Then only it is possible that the boat reaches from A to B along this shortest path, which is straight line path. Here net velocity will be along this vector VV vector, and here this is VR vector. That means VBR should be directed along this direction. Suppose this is angle theta, then only the resultant of VBR vector and VR vector will point along VB vector. From parallelogram law of addition we can see. Now we have to find the direction in which he should row his boat. That means we have to find angle theta and the time taken to cross the river in this case. So we have to find angle theta and time required in this case. We know that VBR is equal to 5 meter per second and VR is equal to 4 meter per second. So let's find the let's first solve this question vectorially. Let's resolve this vector VBR vector. We will get VR vector as this, which is 4, and VBR, let's make its two components along this direction and along this direction. Here we will be getting VBR cos theta, which is VBR is 5 to 5 cos theta, and along this direction we will be getting VBR sin theta, which is 5 sin theta. 5 sin theta. Now if we solve these two vectors, we will be getting next diagram, which is 4 minus 5 sin theta and this vector 5 cos theta. From here we can see that VB is basically 5 cos theta. Now here if we want to direct this VB vector along this path, then these two parts should cancel. That means this should be equal to VB and this part should be equal to 0, because only if these two vectors cancel each other, then the final vector will be pointing along the perpendicular of this VR vector. So therefore we get 4 minus 5 sin theta is equal to 0, or sin theta is equal to 4 upon 5. So we will be getting theta as 57 degree. Here theta will be 57 degrees. So this part is solved. Now we have to find the time required time. We know this is 30 meter. If we know the speed VB, the magnitude of the speed VB, then it is easy. So therefore we can write required time is basically this distance, which is 30 meter, divided by this speed VB. Here VB we can see this is 5 cos theta, so we can write 5 cos of 57 degree. So we will be getting 30 upon 5. Cos 57 is sin 37, that is 3 by 5. So we will be getting 10 seconds. This is the required answer.